Good morning, everyone. I hope you are all doing well. So the last thing that we're going to do for this year, because yes, we are almost at the end, is we're going to look at Unit 13. It's called Series and Sequences, but we're only going to do two things with it. We're going to learn about what an arithmetic sequence is and then what a geometric sequence is. Okay? So we're going to do arithmetic today. We're going to do geometric on Thursday. And then next Monday, I will post your last assessment. It will be the same as it's been, the multiple choice on forms, the 5 questions. And then that is going to be it. The rest of the week and a half after that is really just meant for you to make up any missed work or assessments. And then I will change it in the grade book, and then that'll be it for this year. Okay? So first thing we're going to learn about is what an arithmetic sequence is. And yes, when you see this word, it looks like arithmetic, but there is 2 ways to say it. So when you're talking about it as an adjective, it is arithmetic sequence. That was always something that everybody used to always say when we were back in class, that I was saying it wrong, but I'm not. All right, so first thing is, what is an arithmetic sequence? Well, all a sequence is just a sequence of numbers, literally one right next to each other. And normally what happens is the numbers all have something in common. So an arithmetic sequence is just a sequence of numbers that the difference between the consecutive terms is constant. So for an arithmetic sequence, all that means is if I look at this example, 2, 5, 8, 11, ... It's like you're looking for the pattern. And in an arithmetic sequence, it starts with an A. You're looking for what you're adding to get to the next number. You can add a positive number or a negative number. Okay, but for arithmetic, it's adding. And it's easy to remember because they both start with A. So here, 2, 5, 8, 11, I'm looking for something called the common difference. And all that is the number that you add to get to the next term. Okay? So if we look at 2, 5, 8, and 11, all I want to figure out is, well, how am I getting from 2 to 5? I'm adding 3. How do I get from 5 to 8? I'm adding 3. How do I get from 8 to 11? You're adding 3, which means your common difference would be 3. Okay? Now, if it doesn't have the same, okay, then it's just not an arithmetic sequence. So if you're adding a different number, that's not called an arithmetic sequence. So what we're dealing with, they're all going to have some type of pattern that you are looking for. And over here, I just said you can add a negative number. So basically, if you go backwards, your numbers are going from biggest to smallest, then yeah, that means you're adding a negative number. Okay? All right, so first thing, we're going to just find the common difference. So very plain and simple. Find the common difference in this sequence of numbers. So 5, 11, 17, ... So how do I get from 5 to 11? So let's say 5, 6, 7, 8, 9, 10, 11. I am adding 6. How do I get from 11 to 17? Well, it should be adding 6, but you always want to check. Because if it's not the same, it is not an arithmetic sequence. So 11, 12, 13, 14, 15, 16, 17, we are adding 6. Therefore, we can say that our common difference is 6. And that's all it is. It's very simple. Okay, the second one, find the common difference in this sequence. 95, 85, 75. So right off the bat, I noticed that our numbers are going down. That means we are adding a negative number. Remember, adding a negative is the same as subtracting. So how do I get from 95 to 85? Well, I'm going down by 10. So I'm going down by 10. Okay, let's check to make sure the next two are the same. How do I get from 85 to 75? I am subtracting 10 also, which just means my common difference is negative 10. You just have to remember you need to have the negative there. Okay, so that's the first part of arithmetic sequences. It's just figuring out what you're adding to get to the next number. Very easy. Now, sometimes I give you a sequence of numbers, right? So these are 5, 11, 17. This is the first term. This is the second term. This is the third term. And I want you to find the 20th term. So yeah, if you wanted to, you could sit there and list out all the numbers, but sometimes it gets to be a lot of numbers that you're adding. So that's where there is a formula that you can use. It's called the arithmetic sequence formula, and it's right here. So it says AN equals A1 plus parentheses N minus 1, close the parentheses, times D. So what does it all mean? A1 would just be what term you're looking for. So are we looking for the 20th term? This would just say A sub 20. It would just be what you're looking for. A1, you would plug in whatever your first term in your sequence is. Plus, over here, the N just stands for, well, what term are you looking for? So if you're looking for the 20th term, 20 would go into N. Minus 1, close your parenthesis, and then you're timesing it by D, and D is just your common difference. Okay, so to use the formula, there are a few other things that you need to find out first, but then once you plug it in the formula, it's very simple to get your answer. You just plug it in the calculator. So if we look at 2 questions. So find the 12th term in the sequence 3, 7, 11. So yes, if you wanted to sit there and you wanted to list out all the terms and find the 12th terms, you totally can, that's fine. Okay, but I am going to use the formula since I want to see how to use the formula. So formula, AN equals A1 plus parentheses N minus 1 times the common difference. So I want to write down what everything is so I have it. So we're looking for the 12th term. That is your N value. A1 is just your first term right here. Whatever the first term in the sequence is, our A1 is 3. Okay, and then the only other thing we need is our common difference. So yes, you need to figure out what you're adding to get to the next term. So how do I get to 3 to 7? 3, 4, 5, 6, 7. I'm adding 4. Again, always double check to make sure the next ones follow the same sequence. So 7, 8, 9, 10, 11, we are adding 4. Therefore, our common difference is 4. So now we're going to go to the formula. So AN is what you're looking for. We're looking for A sub 12. And that's just like a placeholder. This is A1, this is A2, this is A3, dot, 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 all the way to A12. So that's all it is. It's just a placeholder. You're looking for the 12th term. So A1, I'm going to plug in 3 because that's the first term, plus parentheses. N is the term we're looking for. We're looking for the 12th term, which means 12 just goes in your N spot. Minus 1, close the parentheses, and then you're timesing it by your common difference, which is, in this case, 4. So the 12th term, plug that right into the calculator. So 3 plus parentheses 12 minus 1 times 4. Your answer is 47. Okay, which means the 12th term is 47. So if you wanted to, yes, you could have sat there and you could have just added 4 to the sequence and gotten to the 12th term and gotten 47 that way, but it's up to you which one. All right, let's do one more. So find the 8th term in the sequence, 82, 77, 72. We are going backwards. So first thing I do is write down what my formula is. Next thing I do is I figure out my terms. So N is what you're looking for. You are looking for the 8th term. A1 is right here, the first term, 82. And my common difference. Well, for 82 to 77, let's see, 82, 81, 80, 79, 78, 77. So minus 5. Always double check. So 77, 76, 75, 74, 73, 72, we are also minusing 5. So our common difference is negative 5. Okay, now we're going to plug into the formula. So we're looking for A sub 8. Again, that's just a placeholder. That's just, you're just calling that the 8th term. A1, which we said was 82, plus N, which is what we're looking for, the 8th term, minus 1, times our common difference. You could put the common difference in parentheses if you want, or you could just do times it whenever you're doing it in the calculator. All right, so 82 plus 8 minus 1 in parentheses times a negative 5. And that is really weird because I did not do these beforehand. I just made them up and they happen to come out to the same number. That's really weird, actually. Like really weird. 82 minus 5, so 1. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. And I just double checked and it is correct. That's really cool. Would have been even cooler if it came out to 48 because April 8th, my birthday. But it's all right. Okay, so I hope that was easy for everyone. It should be. That's all pretty much the extent of what we're doing with arithmetic sequences. And I will post a picture of 4 questions that I want you to try, the same exact things that we just got done doing. And that will be your assignment for this week. That will be your effort participation grade for this week. I will post it today. It'll be due by Friday. And on Thursday, I will post the geometric sequence. I will not have that assignment be due though, so that's just up to you. And then, like I said, next Monday, I will post your last 5-question multiple choice assessment. Okay, I hope everyone has a great day. Bye, guys.